Picture the scene. It's 584 BC on the coast of Asia Minor, the coast of modern-day Turkey. Two brutal tribes are battling on a field strewn with boulders and dead bodies, the Medes and the Lydians. This story is written in Hesiod's work that came to us from the ancient Greeks. These two tribes are hacking each other with swords and blades, with burnished shields and fierce headdresses. Suddenly, in the middle of the battle, the sky darkens. The temperature drops by 10 or 15 degrees. Birds stop singing, animals change their behaviors. And these grown men, fierce warriors, drop to their knees in confusion, and many wander dazed from the battlefield. In this moment, a small course of history is changed because of a solar eclipse. This, for some people, marks the birth of modern science in the ancient Greek age, a time when superstition reigned and people thought an eclipse was angering the gods. Unbeknownst to the people on the battlefield, a man called Thales, known as the first Greek philosopher, had used Babylonian eclipse records to predict this eclipse, down to the day, and that potentially marks the birth of science. Lunar eclipse. When the Earth comes between the sun and the moon, there's a lunar eclipse. The Earth casts quite a large shadow because it's a larger object than the moon. So the moon passes entirely through the Earth's shadow, and everyone on the night side of the Earth can see a lunar eclipse. Because some light filters around the edge of the Earth through its atmosphere, the color of the moon in a lunar eclipse is not totally dark, but is a dull red color. Solar eclipse. When the moon comes between the sun and the Earth, there's a solar eclipse. Because of a coincidence, where the sun is 40 times larger than the moon, but also 40 times further away, the two objects subtend the same angle in the sky, half a degree. And so, when the moon comes between the sun and the Earth, it almost perfectly blots it out. What that means is the shadow comes to a near point on the Earth's surface. So the fraction of inhabitants of the Earth on the sunlit side that see a total solar eclipse is very small. A larger number of people will see a partial solar eclipse. Because the Earth is spinning during the eclipse only lasts a few minutes. The range of duration typically from 2 minutes to a maximum of about 6.5 minutes. Not all eclipses are total. Total solar eclipses are the rare occasion when the moon is almost exactly the same size as the sun seen in the sky. But while the Earth-Sun distance varies by 4%, the Earth-Moon distance during the orbit varies by 10%. So the moon does not always subtend the same angle as the sun. When it subtends a smaller angle, a rim of sunlight is visible around the moon, and that's called an annular eclipse. If the Earth, Sun, and Moon all traveled in exactly the same plane, then we would logically see both solar and lunar eclipses every month. But that's not true, because the plane of the Earth-Moon orbit is tilted by 4 or 5 degrees with respect to the Earth-Sun plane, which is defined by the ecliptic. That means there are only 2 times a year when the so-called nodes line up when there's most likelihood of seeing a solar or a lunar eclipse. The rest of the times in the year, the alignment is not perfect, so essentially the shadow misses. The details of the frequency of solar and lunar eclipses depends on the details of the Earth-Sun-Moon orbits. And because those orbits are non-uniform, and because the distance between the 3 objects varies during their cycles, during the lunar month and during the solar year, calculating the eclipses, their visibility and their duration, actually needs a careful orbital calculation. Eclipses were occasions of mystery, wonderment, and superstition in ancient history. Now we understand what causes them, and so we can predict them into the future. Solar eclipses were rare. Because of the small fraction of the Earth's surface covered by a solar eclipse, before the age of mass transport, it would be very unlikely to see a solar eclipse in your lifetime. So obviously these were very special events. Lunar eclipses, on the other hand, can be seen by a large fraction of the population of the Earth on the night side, and so many people have seen lunar eclipses. These days, astronomers travel around the world to catch solar eclipses. One solar astronomer I know who works in Massachusetts, I think, has seen 60. I'm pretty far behind on that. I've only seen 3 solar eclipses, but they are indeed spectacular events. In the United States, we're lucky because we get the next major solar eclipse. It's actually called the Great North American Eclipse, which will occur next summer, as the path of totality tracks across the Midwest. Scientists no longer learn so much from solar eclipses as they used to, because we understand the workings of the sun very well. But also, amateur astronomers' equipment has improved dramatically over the last few decades. So for a couple of $100 with some fairly sophisticated equipment, you can generate wonderful pictures of a solar eclipse yourself. If you've never seen a solar eclipse, I recommend going out of your way a little bit to catch one. Eclipses are spectacular phenomena of the daytime and nighttime sky, caused essentially by coincidence that the moon subtends the same angle in the sky as the sun. Solar eclipses are much more rare than lunar eclipses because to see a solar eclipse, you have to be in the point of the shadow that the moon makes from the sun, whereas with a lunar eclipse, you can be any time or pretty much any place on the night side of the Earth.